Good morning, students. Welcome to today's class. We have already discussed about the J. Thomson model of an atom, Rutherford's model of an atom. Today, we are going to learn about the Bohr's model of an atom and about the neutrons, that is the third subatomic particle. So, we discussed about the protons, that is positively charged particles, electrons, which are negative charged particles, and neutrons, which are neither positive nor negative. So today we are going to discuss about these two. So Niels Bohr has put forwarded the following postulates. So what are the postulates? Only certain special orbits known as discrete orbits of electrons are allowed inside the atom. So we know that from the Thomson model of an atom, three subatomic particles are present, and you have already learnt about the drawbacks of Thomson model of an atom. That is that they move in a circular orbits and they accelerate. Due to that, there will be a loss of energy, and because of loss of energy, certainly they fall into the nucleus, so the atom becomes unstable. And in the Rutherford scattering model of an atom, he has also, there was also some drawbacks. There were some drawbacks in the Rutherford's model of an atom, right? Now here, so what Niels Bohr has told, there only certain special orbits. So what he is saying is the electrons will be revolving in certain special orbits, and those orbits are nothing but called as discrete orbits. Okay, so these discrete in this discrete orbits, while the electrons are revolving, then they do not lose their energy. So these were the postulates which are given by the Niels Bohr, the postulates of Niels Bohr. So these orbits or shells, the orbits are also called as shells, and they are called as energy levels. So the orbits or the shells are called as energy levels, and these energy levels are represented by the letters K, L, M, N and so on, or in place of K you are writing it as N, small n, that is equal to 1, 2, 3, 4 and so on. So here in this picture, children, we can see this is a increasing energy of orbits, that is when n is equal to 1, n is equal to 2, n is equal to 3. So increasing energy of the orbits, and this is a nucleus, and n is equal to 1 is nothing but the K shell, n is equal to 2 is L shell, n is equal to 3 is M, and n is equal to 4 is N shell and so on. So each and every there are some orbits known as discrete orbits, and electrons will be revolving only in this discrete orbits, and when they are revolving in discrete orbits they do not lose their energy. So that was told by Niels Bohr. So here if you see the first shell, this is the nucleus which is present in the middle of an atom, which is equal to the number of protons and neutrons, right? So first shell n is equal to 1, the first shell, that is K shell, there will be 2 electrons. Okay. Now second shell, that is the L, KL, second shell, there will be 8 electrons. Okay. So 8, how did they count? 2 here, 2 plus 2, 4, 5, 6, 7, 8. So this 8 plus 2. So total 10 electrons will be there. Okay. Now third shell, that is KL and M shell. So third shell is M shell, and M shell will have 18 electrons. Okay. 18 electrons in their outermost orbit. So this is about the Niels Bohr, and tomorrow's class we will discuss about the Bohr-Bury scheme about the arrangement of electrons and about their valencies. Okay, children. Now, what are neutrons? So, we already learnt about the protons and about the electrons. So, protons are positively charged particles, and which was discovered by the Goldstein, and electrons are negatively charged particles, which was told by the J. Thomson, but in detail to know about the arrangement of electrons, that was given by Rutherford. So neutrons, about neutrons in the year 1932, James Chadwick discovered another subatomic particle called as neutron. So in 1932, he discovered another subatomic particle called as neutron, which has no charge. So neutron means it does not have any charge. Either it is not a positive charge or it is not a negative charge. And a mass is nearly equal to that of a proton. So neutron mass is equal to that of a proton, and these neutrons are represented as small n. So E represents electron, P represents proton, and N represents the neutrons. The mass of an atom is given by the sum of the masses of protons and neutrons. If you want to say the mass of any atom, you have to calculate the protons and neutrons. Sum of the masses of protons and neutrons present in the nucleus is called as a what you call the mass. The mass of an atom is given by sum of the masses of protons and neutrons present in the nucleus. So here you can see the helium atom, that is alpha particle. So alpha particle is nothing but the doubly charged helium atom, right? So here you can see that very clearly, helium 4 2. So 4 is nothing but the mass number. This is the number of neutrons and protons. So mass number will be represented at the top, which is nothing but the sum of the protons and neutrons present in the nucleus of an atom. Okay, and here the down 2, helium 4 2, the 2 is nothing but the protons. This number lets us know how many protons are there. So this 2 will say that how many protons are present in the nucleus of an atom. Okay, so in a neutral atom, if it is neutral, this is also the same as number of electrons. So here the middle one, that is called as neutrons and protons. The protons and neutrons together is present in the nucleus, and the yellow color ones, what you can see, that is nothing but the negatively charged particles, which are electrons. So here this is a helium atom, the second element in the periodic table. The first element is hydrogen, the second element is helium. So outermost electron, this is gray color, that is nothing but the negatively charged particle electron. The positive is proton, which is red color, and neutron is a blue in color. So protons plus neutrons is present in the nucleus. So sum of the protons and neutrons is nothing but the mass number. So the mass of an atom is given by the sum of the masses of protons and neutrons present in the nucleus of an atom. So this is regarding the neutrons. Okay, children. So hope you understood the Neil Bohr model of an atom and about the neutrons, the third subatomic particle, that is about the neutrons. So next class we will discuss about the, as I told you, like valencies and how the electrons are present, the arrangement of the electrons in the different orbits, that is nothing but the discrete orbits, or which is also called as the shells, that is K shell, L shell, M and N shell for different elements. So read the textbook, children, for your better understanding. Thank you. Have a wonderful day.